Okay, here's chapter 6 test review for Algebra 2. Here we go. Number 1, number 2. The instructions are simplify the expression. And these are the type of expressions you'll be up against. One of them is something like this. And the variable they use, I'll use their same variable, but it doesn't mean anything special. They're just using e. They could have just as easily used x. Okay, so maybe 65e to the 8th over 13e to the 5th.
So does that mean like e as in?
No, there's nothing special about it. It's just a variable. So the answer will have an e in it. Don't try to interpret it. Don't use it. It doesn't mean anything special here. I don't know why they used e, but they did. What do you think the answer is?
Whatever 65 divided by 13 is to e to the third.
Well, 65 divided by 13. Does 13 go into 65?
Yes. That's 5.
It's 5. 5 what? E to the third. Done. That's all that's expected. Y'all see it? Okay. The other one that says simplify each expression. Number 2, in other words, this was number 1. This is number 2. Number 2 is something like this. 4 e to the, using e again, it's nothing special. E to the, I don't know, negative 3x to the third. Any ideas?
Cube 4.
Yes, that's the thing that people forget the most, is they forget that that cube belongs to that 4 as well. So you take 4 cubed first. It applies to this and it applies to this. People forget because there isn't an exponent right there to remind them. You have to remember. So 4 to the third is 64. And then what do we do with the exponents here? Times them, so you get what? E to the negative 9x. Yeah, do you see that? It's 3 times 3 times x times a negative. Yeah. You really should express this, whatever it is, with positive exponents when you're done. That should be the answer. If you give me this, I'll probably give you full credit, but then I'll be in a bad mood for the rest of your test. You don't want that. You should express, because these are both technically correct, but you really should express to be completely correct and kosher with everybody that's reading this thing, which is me. You should make your exponents positive before you're done. And that goes downstairs to make that positive. Okay? Anytime you want me to stop and wait for you to finish writing or ask a question or whatever, let me know. Otherwise, I'm going to keep plowing ahead. Because I want to try to get through. I'm pretty sure I've got enough time to get through. Anyway, the next instruction says, rewrite the equation in logarithmic form. It looks something like this. Hmm. 15 to the negative 3 equals, oh boy, I gotta make sure this works out right. Hang on. That's not what I want. Don't write that down. Let's make it 8 to the negative 2. 8 to the negative 2 equals 0.015625. That is what it equals, but it's just important. It's kind of important that that it actually be an equals, but that's not important what you have to do. It says rewrite the equation in logarithmic form. So you've got an exponential equation there. How are you going to write it in log form? Anybody? That's a good start. Log base 8, because the base of the exponent is 8, so is the base of the log. And then of what? Log base 8 of 0.015625 equals negative 2. Do you remember that? Do you remember the very, very first thing I showed you and said you have to be good at this before you, that's what we're using. Do you need me to write that down for you? Anybody want me to write down that? Okay. The next one has another set of instructions. Number 4 says evaluate the logarithm. Number 4 is something like this. The log base 36 of 6. Now here's what they want you to do on this. This is what they wish you would do. And if you're going to show me any of your work, this is what you'll do. You just say, I don't know what that is. So I'm going to say it equals x, and then I'm going to change that to an exponent. Remember how? 36 to the x, yeah? Equals 6. And then you got to ask yourself, what can I raise 36 to get 6? And then you think, oh yeah, the square root of 36 is 6. That's the relationship there, which means that's got to be a half. That's what they're hoping you'll do. Here's what you can do instead. This is what we wanted to evaluate, the log base 36 of 6. I mean, in this chapter, as we went along, we learned how to evaluate this with a calculator. Right? Change your base rule. So you can do it that way if you want. Just make sure you enter exactly what you intend, because there will be no work to show me and I can't look in your calculator. Make sure you get the right answer. Maybe do it both ways. I don't know. But you would go common log of 6 or natural log, either one. Common log of 6, make sure you close the parenthesis, divided by the common log of 36. Close the parenthesis, and you get amazing 0.5, which is exactly what we got here by reasoning it through a little bit. 0.5 or 1/2, I'll take either one. But if you choose to do it exclusively with your calculator and you miss the problem, you will miss it all. Just so you know, because I have nothing I can see that causes me to, I have no idea what you did, and I'm not here to think for you, so you need to show me. So if you don't want to show me and you're absolutely certain you know what to do and they ask you to evaluate this, you put it in your calculator, write down 0.5 and move on. If you're correct, I'll give you full credit. If you're not, I'll give you nothing. Just saying. Okay? Number 5 says simplify. That's the instruction. And this is what you're simplifying, something like this. The log of, no, not that. Don't write that down. 10 raised to the log of 3x plus 1. Just to simplify that. Anybody know the answer to that? The answer to that is 3x plus 1. Because you have an exponent base 10 in the same expression with a log base 10, and they are inverses. They undo each other like square rooting a square. Does that make sense to you? Okay, so we have an exponent base 10 and an understood log base 10 right here, inverses. So we're left with 3x plus 1 when they undo each other. That's something you got to kind of remember. That's not something you can figure out. So you'll either get that one right or you won't. Probably. Something like that. Okay, next one. Says, find the inverse of the function. So number 6, under those instructions, find the inverse of the function. Of course, labels here. Okay. You'll have to find the inverse of something similar to this. Y equals, I haven't seen any natural logs. Let's do that. The natural log of x plus 3. The instructions are find the inverse of this. Whenever the instructions are find the inverse of something, what's the first thing you do? Switch x and y. Good. X equals the natural log of y plus 3. Then what do you do? Yeah, you do the best you can to solve for y. How are we going to get at that y? It's trapped behind that logarithm.
put E on the other side.
Yeah, you E it. Remember I told you that about the calculus students? You gotta undo that log. You can't get at that y plus 3. It's stuck behind that logarithm door and you can't undo it unless you use an inverse, which means if you've got a log, you want to change it to an exponent, or in other words, you E it. See the E right there? Y'all see it? You take E, raise to the other side, equals what you're logging. That's that one thing I told you, you gotta be able to do it. You gotta change logs to exponents. So there's that move. That liberated the y and the plus 3. And now we just gotta get rid of the 3. And that's the inverse. And you don't have to write f inverse because they won't tell you this is f of x. I'll start out with a y. You can end with a y equals this. That's fine. I'm looking for this, for the right answer. And if it's wrong, I will be looking for this. So you do the switching, and you've got a logarithm. You've got to get at that y that's now tied up in the log. You got to undo the log by doing its inverse. You got to E it. You take E raised to the other side, change it to an exponent. In other words, E raised to the other side equals what you're logging, y plus 3. Now that these are liberated, we can get rid of the 3 easily. Yes.
Why do you raise the x?
Because that main thing, I'm going to erase some of this because I'm going to leave room anyway. That main thing that we did said that if you have the log base b of x equals y, that's the same thing as b to the y equals x. And so if I put that right underneath there, I've got a logarithm, which is, I have the natural log of y plus 3 equals x here. That's kind of resembling this, except for the x's and y's are switched up and stuff. And so what I did here is I took the base of this, the base of the log, raised to the other side equals what I'm logging. Same thing here. The base of the log raised to the other side equals what I'm logging. That's e to the x equals y plus 3. E raised to the x equals y plus 3. Then I swung the 3 over.
So you changed it in the.
Yes, I changed the log to an exponent, basically. Yep. That's what my kids call E-ing it. We got rid of the log by changing the logarithm to an exponent by taking e to the x equals y plus 3. You see it? Okay. All righty. That's number 6. Find the inverse. Okay. Next one, number 7 says, and it's under these instructions, write a rule for G that indicates a transformation of the graph of F. And f that they give you in number 7 is reminiscent of this. F of x equals 3 to the x plus 2. Nah, let's make it just to the x. Kind of like a parent function. Okay? And this is what you're supposed to do to it and write the g function. It says, write it so that it has a reflection in the, let's say, y-axis, followed by a translation reflection axis followed by a translation 5 units left. You got 2 transformations to do, right? This is a good time for that intermediate h of x. So you can affect the first one, get it all cleaned up, and then affect the next one on that one. So if I say h of x, that what we're supposed to do is a reflection in the y-axis. That means f of negative x. That makes sense? That's a generalized reflection in the y. Specific to this one means 3 to the negative x, because wherever x is in f, we'll replace it with negative x to get it to reflect over the y. You see that? That's h. Now it is to h that we will cause a move 5 units to the left. So g, which is the next function, is going to be h of x plus 5. That'll move h 5 units to the left because that's the next one. Does that make sense? Or not? And making that specific to h, which is this, would be 3 to the, we replace the x, just the x, with x plus 5. The whole thing's still negative. Do Do you see that? Because the x got replaced with x plus 5, but whatever x was is still negative. So the final answer should be 3 to the negative x minus 5. People miss this problem all the time because they get this sign right here wrong. You know why? Because they do this instead. That only changes the sign on the x. It's negative whatever the replacement for x is. And the replacement for x, according to what's right here, is x plus 5, and it's the negative of the whole thing. That negative belongs to everything that x became. So that's the correct answer, and it's tricky. Okay, number 8 is either really easy or you just don't know what you're doing. So I'll try to walk you through it. It gives you a formula for the height of an object being 3D printed. Have you ever seen a 3D printer? They're pretty cool. Here's what it says. The height h of a container being printed by a 3D printer is related to the radial position r by the equation. You don't have to know any of that. You just have to look at the equation they give you. And the equation is not going to be exactly like this, but this says by the equation h, and they use a capital one, of r, meaning the height is a function of the radial, whatever they were talking about, that r right there. And it's, according to this particular printer, is something like 2.1 times 1.3 raised to the r minus 1.4. Strange equation. You don't have to know where it comes from. You don't have to know anything about 3D printers or radial positions or heights or anything. You just got to be able to read this, because here's what they want you to do. They give you this formula in the problem, and they say, describe the transformation of this one. F of r equals 1.3 to the r. So this is not part of the transformation. This remains the same. But these are pieces of transformation getting from h of r to f of r. How is this one transformed from this one? Can you list it? Can you list the transformations?
Down 1.4.
Down 1.4. That's not the first one you should list, but okay. The vertical stretch should go first because it comes first in order of operations. Multiplication comes before subtraction. So vertical stretch of 2.1. And if this had been 0.8, you would have said vertical shrink of 0.8, right? So that's how this is transformed from this. So they give you this first, they give you this last. So here's your parent, and they want you to do this one. So make sure you switch around in your mind. And then it says, then use the function, meaning this one, to determine the height of a container when the radial position is 0.7. So now you got to do this. You got to do h of 0.7, meaning 2.1 times 1.3 to the 0.7 minus 1.4. Thank goodness for calculators. You understand that's what that means? It says to find the height when the radial position is 0.7. So we put that in for r and do the calculator. And your calculator can do all this all at once if you put it in exactly the way you see it there. 2.1 parenthesis, 1.3, close it, raise to the 0.7, get out of there, get out of that exponent, and then subtract 1.4. And I get 1.12. About. So you put a dot on that, indicates to your reader that you know you approximated. You don't have to do that. It's good math to do that. You understand how that one's going to go? Let me show you the answer sheet on this one. Number 8, that's one we were just doing, looks like this. It says 8, has a couple of lines. Guess what's going to go on those 2 lines? Any transformations. And there may be only one. Or maybe there's 3, but you got to fit it in those 2 lines, okay? And then what do you suppose? It says height. What do you suppose you're going to put there? What one, two? So this is what I was talking about on there. It looks like that for number 8. So you know what it's going to be. Okay. Number 9. Number 9 is one of those ones like I talked to you about earlier, when you and your friend or you and your brother or whatever both have two different accounts. One of them is represented with a graph and one of them is represented with an equation. And you have to be able to think about both of them and make comparisons. So let's say that it says, all right, so it's going to be you and your sister or somebody, but your parents are going to get a couple of accounts, but they get them at different times, so they're different types of accounts. And here's what it says. Your parents invested money in a college savings account when you and your sister were born. The balance A in dollars of your account after T years can be modeled by, and I'm making this up, so I don't know how this problem is going to turn out, but this is your account. The amount in your account at any given moment is, we'll say, $4,300. That's the amount your parents invested. E to the 0.04T.
And it'll have that equation.
Yes, we'll have that equation. It says, this is what it says. The balance A, which is right there, of your account after T years can be modeled by this. The graph shows, which I'm going to have to draw a decent graph. I don't know how I'm going to do it, but I'll try it. The graph shows the balance of your sister's account over time, which account has the greater principal, and which has the greater balance after 10 years. So your sisters will be represented by a graph like this. And we'll have numbers all up along this right here, which is dollar amounts, and this will have years out down here, and it tells you that. And we'll say that this is, this is 4,000, and this is 5,000. It's much better than what I'm doing, but like that. And then it said, and then it will go up like this. And after 10 years, let's see, 5, 6, 7, 8. I have no idea how this is going to work out, but I'm going to say that 10 years is right here. It's all stretched out beautifully. And now we've got to decide who has the greater principal. What do you think? This is you. This is your sister. Who has the greater principal?
Sister.
Your sister. It's closer to 5,000. Yours is closer to 4,000. Hers is about there, about 5,000. Okay. You don't have to know exactly what that is or figure out exactly. You just got to recognize that the beginning amount on this one is higher than the beginning amount on this one. You have to be able to recognize it out of both representations. Then after 10 years, your sister's account is up to about here, which is going to have to go up a ways. That's 5, 6, 7, 8, 9. We'll say 9,000. It'll be clear and it'll have grid marks. We'll pretend that actually is right around 9,000. What's yours after 10 years? Plug it in, do that. $4,300 at 10 years is going to be equal to, I mean, that the one yours is going to be equal to what?
6,414.
6,400 and what?
14.
Man, your parents really don't like you. They didn't put as much in and you didn't make as much either. That's because I drew this and made it up. Okay. Had this thing not grown quite so fast or something like that, we start right there. Maybe they had a little more money when your sister was born or something, but it didn't grow nearly as fast like this. And you go up here to 10 and go over here and you say, ooh, that's pretty dang close. But they're hers. If it actually comes over here, she actually had a little less at 10 years than you did. You with me there? But it'll be very clear. It'll be gridded out. You'll be able to tell. But you have to be able to use representations graphically and representations with an equation to make comparisons. And that's what they will ask you. Who has the greater principal? Who has the greater amount after 10 years? That's what they ask. Most people get that one right. Most people miss this next one. So try not to be one of those. The next problem, number 10, talks about depositing money and letting it grow, and how much do you have after a while? And most people miss this because they can't remember the formula. It's not provided. So listen to the problem. I'm going to change the numbers, but not the context. Your friend deposits $13,500 in an investment account that earns 3.8%. find the balance after 8 years when the interest is compounded monthly. What's your formula going to be? If you don't know this, you can't do this problem. And this is where people miss it. They can't remember the formula. Anybody remember it?
A equals E parentheses 1 plus E
Nope, 1 plus
R
R over N to the
and T.
NT. And you have to know what all those things represent too. So how much did this guy invest? That's the first thing is P. What?
38.
I said 13,500, didn't I? Is that what I said? I think that's what I said. And what was the interest rate? 3.8? Yes?
Yeah.
Here's where other people miss it. People will put 0.38 here. That's 38%, people. 3.8% is this. You have to move it twice. 3.8%, got to swing it over twice. There's a zero in there. If you forget that, you're going to be making money at 38%. You're going to make a lot of money. Divided by how often are we going to compound? Pardon? Monthly? What I'm going to put here? 12. Raised to the, how many years we're leaving this invested? 8, I think I said. And if you can remember this and remember where things go and make that interest rate 0.038 and not 0.38, and remember there's 12 months in a year, all that stuff, you get it all plugged in. There's no algebra to do. This is what we call a plug and chug. But you can't plug if you got the wrong thing right now. So I'm going to write that 13,500 parenthesis 1 plus 0.038 divided by 12, and it understands order of operations beautifully. Close that parenthesis, raise it to that, and while you're in the exponent, write 12 times 8. You don't even have to do the arithmetic. Just make sure you're in the exponent for both of them. Get out of there and hit enter. 18,287.35. People who get it right to the penny. People who get it wrong haven't got a clue because they forgot the equation. Get this in your head before tomorrow. Not only get it in your head, remember what everything represents so you can put things in the right place. You're going to need that for this number 10. Everybody good to hear? Moving on, number 11 says expand the logarithm. So now you can use properties of logs to take a single log and stretch it out into sums and differences. Don't forget that powers become pieces of product as well. So you have to expand something like this. Log base 4. Don't forget the 4 on all of the pieces of your expansion. Log base 4 of something like x to the 5th over 5 y to the 4th z to the, let's say root z. Okay, so we have to expand that. What's the first term going to be?
Log 4.
5 log base 4 of x. Would you agree with that or not? Any exponents on here come down around the front of the log as you log it. So the 5 came down here, but it's still log of this x. And it's log base 4 because that's log base 4. What comes after that? Minus, exactly. Minus what?
Log 4.
Log base 4 of
5.
just 5. A lot of people will put 5y squared. They think those two things are inseparable. They are not. So it's just 5. And then?
4. Wait, can we just put y?
Nope, minus 4, not just y. Minus 4 log base 4 of y. You're logging every term.
But if the 4 times log base 4, does that cancel out?
No, what you're thinking is this. It's different. The log base 4 of 4 is 1. But 4 log base 4 needs something to log. Okay? Yeah, it's not the same. It's a good observation now, but not quite right. So we leave the y there, and then there's one more. What will it be? Plus or minus?
Minus
What?
log
1/2 log base 4 of z. The place where people miss this, like I told you before, is sometimes they lump the 5 and the y together in one term. Can't do that. Here's what you should do when you're done to check it out. Every log should have one thing behind it. Just one, not powered, not anything. Just one item behind it. And you should have 1, 2, 3, 4 items, meaning terms. Any exponents should be on the front of those. Things in the bottom should be negative. There's a lot of things to check on. Okay. So that's an expansion one. That's number 11. Guess what the next one is? Condense it. Condense the log. So we have something like this. The log base 3 of 4 plus 3 log base 3 of 6 minus the log base 3, that's a log, of 8. This one's going to come out extra special. It won't be this special on the test. Anyway, let's get these things together. What would it be? One single log base 3 of what?
4 on top. Plus
6 to the third.
or times 6 over 8.
You think you're done?
No.
You're not.
6.
What does this work out to be? So you would write the log base 3 of 108. I told you it was going to be extra special, but I forgot about this 3 right here, so forget that. I was thinking it was just going to be 4 times 6 over 8, which would have been 3, and the log base 3 of 3 is 1, but this turns out to be 108. That's what I expect to see. I don't want any more than that. I don't want you evaluating that. I want this. I want this simplified as much as possible behind the log base 3. Okay? And it will be like that. There will be numbers that are put together in a proper way here. You need to simplify that as much as possible to stick behind that log.
So you don't want us to
Evaluate it. No,
solve it?
because it says condense the log. It does not say evaluate it. It says condense it, and that's condensed and cleaned up. That's condensed right there. That's, yeah, got to clean that up, but these numbers can be reduced to something a little small. Okay. Next one says, there are 3 of them, no, 2 of them. And it says, describe the transformation of f represented by g. So they will give you a simplified version, a simplified thing that's called f, and they'll give you g that's been transformed, and you have to list the transformations like this. This would be an example of number, I guess this one was number 12. 13 over here, and it's something like this. Maybe f of x equals e to the x, and g of x equals something like this. 2e to the x plus 4 minus 3. How is g different from f? Describe the transformations one at a time in order.
Vertical stretch 2.
Vertical stretch 2. Left 4. Down 3. Do y'all see it? You do? Okay, that's 13. 14 is like unto it. Only it's a logarithm, I think. Yep. 14 has the initial f of x as a log of some kind, and it is the, it's ugly. I'll go ahead and use the same base so you're not flummoxed by it. They use base 1/2. That's okay, as long as they're both the same base, and they are, of x. And g is, I've got room over here, so I'm going to put g down here. G of x is going to be something like this. The log base 1/2 of 1/3 x plus 7. Something like that. Anybody?
Horizontal stretch of 3.
Yes, horizontal stretch of 3. Because we're inside, you have to use the reciprocal, remember? And because the reciprocal is greater than 1, it's a stretch. And of 7. That's all. If I had put a 4 right here, what would you say it is? What would be in addition to this?
Vertical stretch of 4.
Vertical stretch of 4. What if I put a -4 in the front of it?
Vertical stretch of 4.
Vertical stretch of 4 reflected over the x-axis. So could have any of those things in there. Everybody good on 13 and 14? You guys are pretty darn good at these transformations by now. And because Taylor answered first and was correct, she's pretty good at them now too. Studied hard. That's a steep hill to climb when you haven't been doing it for years like you guys have. Okay. Next one says, use the change of base formula to evaluate. So they're telling you what to do. Nobody misses this one. Nobody misses this one. And if you miss it, you miss it all because it's a calculator thing, which means it's not worth much. So it says, use the change of base formula to evaluate. And then it gives you something like this. Do you know how to make your calculator evaluate that? You have to know the change of base rule, but either that or you have to know where to find in your calculator a place where you can put a base in. I don't know that. Either way is fine with me. It says use your calculator to evaluate. No, it doesn't. It says use the change of base rule to evaluate, which means a calculator. So you would go, I'm going to use natural log. You can use common log. I'm going to go natural log 71, close the parenthesis, don't forget that, divided by the natural log of 4. Close that. And I get 3.07 to the nearest hundredth. That's close enough. Is that what you're getting? Okay. So that's an easy one. It's not worth much. Nobody misses it. You'll be good. Next one, number 16. 16 and 17, both of them say solve the equation. And just about everybody gets the first one right, and not very many people get the second one right, so pay attention. Solve the equation. It says they're both log equations, and one of them is like this, and don't expect this to come out pretty because I'm making it up. Okay, the log base, let's say 7 of x minus 2 equals 3. When it says solve the equation, it means we're looking for a value of x that makes this true. How are we going to get at it? How are we going to get at that x? Change it to an exponent. Very good. In this case, if it's not it, it's 7it, right? What do you write? 7 to the third equals x minus 2. What's 7 to the third? 343. So 345 is the answer. Most people don't miss this one. Next one, a lot of people miss because they forget one thing. It's pretty important. It's right at the beginning. If I have the log, again, don't expect this to come out pretty. If I have the log base 6 of 3x plus the log base 6 of x minus 5 equals 3. Solve that equation. Again, it's not going to come out beautiful. Don't expect it to.
Combine your logs.
Exactly. That's where people screw it up. You've got to get those logs condensed into a single log before you can do this kind of thing to it. This already had the log all together. This one doesn't. You have to use your condensing skills to get those together. And what would it look like if you condensed them?
Log base 6, 3 x times x minus 5.
Yep. One log of a product, because that was a log of a sum of two logs, it becomes a product here, equals 3. Now we are in the same boat we were here. What do you do next? Change it to an exponent. 6 it, right? So it'd be 6 to the equals, distribute this as you write it down. What do you get?
3x
3x squared.
minus
And at that point, you should recognize you got a quadratic going now. And we're going to have to kick that 6 to the third over there. It's going to be 0 equals 3x squared minus 15x minus 6 to the third. I'm going to leave it that way. I happen to know what 6 to the third is, but you probably don't. You don't need to figure it out. Calculator can when you go to use the Holyrood finder, because this thing is not going to factor. You might be able to factor a 3 out. Probably, yes, you could factor a 3 out, but it's not necessary. Apps 9. Holyrood finder, second degree, next 3. Minus 15. Minus 6 raised to the third. I get negative 6.35 and 11.35. Is that what you got?
yeah.
You able to use your polyroot finder, or are you just being lazy and letting me do it? Because I hope you know how to do this. Should be getting the same things I do. However, it's likely one of these isn't going to work. How come?
It makes you square or log it.
Can't log a negative. So as soon as I put the negative 6.35 in there, I have 3 times a negative, which is a negative, and I can't log a negative. But again, I'm not rejecting this because it's negative. Rejecting it because it caused me to log a negative right here. Now see if this one will. 3 times 11 something is still going to be positive, right? And 11 something minus 5 is still going to be positive. So we'll keep this one. And this is the way I would like you to write the answer. I don't remember which one this is, but this is what I want to see in the answer. Something like that. So I can tell that you consider the extraneous solutions. Ready to go on? Next ones are inequalities. And I feel like the best way to handle an inequality is with your calculator. And I don't think it's going to be as nasty as the one that, I think you brought it up yesterday, didn't you, Jarrett? That one where we had to squeeze it down and see if we could get that. It's not going to be that bad. Okay, so number 18 is something like this. And it asks you to, it's a range of values that you're going to write for the answer. It's going to have inequalities in it. And so it's something like this. If you have 4 to the x greater than 84. You want to know the values of x that make that true. What are you going to do? How are you going to make your calculator help you with that? Yep. So I got to get out of my polyroot finder, go to my y equals, make sure the plots are off, because if you have a plot turned on that's dealing with data that has nothing to do with this, your calculator has a real struggle with it. So dump all of the equations and make sure your plots are off when you go to graph this thing right here. It's going to be 4 raised to the x and the horizontal line 84. Make sure you design a window properly. Think about the size of x. Do you realize that 4 to the third is already 64? So x is already not very big, but we're already close to this. I wouldn't let x get any more than 5. Maybe not even that. So on the window, I'd go from 0 to 5 for the x's, because remember what x is doing. It's powering 4. And then on the y's, I've got to be able to see that line, y equals 84. So I'm going to go from 0 to 100 by 10s. See what I get. This is what I get with that kind of a window. If you think about it, then you can see, you can very clearly see the intersect. You get something like that? You've got to have your y's big enough to see that y equals 84. So that's why I went up to 100. You've also got to have your x's be small enough that you can see this thing growing. Because if you let x even go out to 10, it's going to take off. And you just go 0 to 10 because you don't know what else to do. It's going to go like this. You'll still be able to see it, but it would be nice if you understood that x can't get very big to get to 84. So we find the intersect. And we get 3.196. So for the blue one to be greater than the red one, which is the line, x has to be greater than 3.196. And as long as x is bigger than that, then the blue one will be bigger than the red one. Does that make sense? You see how to interpret it? Yeah, good. Most people get this one right too. Next one has to do with a log. Let's say we had something like the log, this is 19, the log base 8 of x is greater than or equal to 4. We want to know the x that satisfies that. So how do you graph this one? You either know in your calculator where to find a log that you can put an 8 on, or use the change of base rule. And I don't learn that other one. I don't need it. To graph this side over here, I will graph the common log, or log base 10, the log key of x, close it, divided by the common log of 8. That's using the change of base rule to graph. Do you see that? Log of the big one over the log of that one, we'll graph that side, and then I need a 4 in the other one. Okay, now this time, the horizontal line is only going to be up 4, so you're going to want to adjust your y's down to about 6 or less, so you can just see the 4. So I'm going to let my y's go from 0 to only 6 this time by 1s, but it's the x's I may need to go out a ways. Think about what x is. It's saying 8 to the 4th. If you change that, if that were an equal sign, that's where your boundary is going to be. 8 to the 4th, pretty good sized number, isn't it? 8 to the 4th? It's in the hundreds. So that means you want to let your x values, which is what 8 to the 4th would give you, is x values, because if you do the change, you want to let x's go out a long ways. So I'm going to let my x's go out to maybe 1,000, just to make sure I count for all my hundreds by hundreds. Ooh, still can't see it. Can you see it? If I go out to 1,000 there, I still can't see where the blue is going to cross the red. Go to 10,000? Okay, so you just keep expanding your x's out till you can see it cross, right? So you said 10,000, I'm going to go by thousands, okay? Oh, there you can very clearly see it. If we go out 10,000 on the x. So if you can't see the cross point, but you're pretty convinced you will, then expand your x's out till you can see it. There we go. Second calc, intersect. And it looks like 4,096. So as long as x is more than or equal to 4,096, if I can write it right, as long as x is bigger than that, the log of that will be bigger than 4. Because what you're looking for is when is the log, which is the blue curve, when is it more than that line y equals 4, and that's from this point on. You following? Okay, so you just got to keep expanding your window out until you can see where they cross. That's how you evaluate those inequalities.
On the
Yeah.
test, will there not be lower bounds?
I'm sorry?
On the test, will there not be lower bounds, or will they be different?
Both of these are greater than that, so there will be. You okay, everybody? Yeah.
What ones do you press to find where they intersect?
Let me show you. It's anything that you're on the graph you want to calculate. It's in this calc you can call it right there. It's another choice. So you go second, you can go second and calc, go down to intersect. You just, now go ahead. It says, is this the first curve? And then it will ask you, is this the, you just hit enter. It is. It's blinking on the first curve. Am I blinking on the second curve? Yes. You want to guess? No. Just hit enter. If you only have 2 curves in there, when you go second intersect and come back to here, just go enter, enter, enter. That'll answer all the questions. Because this X line is bigger than the Okay, number 20. I'm not going to go through this one because I went over it with you yesterday. So the people on the review that were not here yesterday either are going to be in the dark. But this is the Newton's law of cooling problem. The one that says you got to find R and then you got to use R to find the capital T. You remember? So you should have some examples of those that you can work out. I'm hoping the people that are missing today were here yesterday because I'm not going to go over it again. It takes too much time. 3 more problems, and it's really weird because I chose these problems out of a test bank, they call it. And so they have certain types of problems They go along, and then they change it to a different type of problem, and then they start the numbering system over. So this next part is a multiple response. So it's multiple response number one, but it should not be a problem because that's what I have. Multiple response number one. It shouldn't be hard to find. It's the next one down after doing number 20. Okay? And it's like, what multiple response means that any or all of the options could be true. So it says, which equations are correct? There are 5 of them. Maybe one of them is, maybe none, in which case you write none. If they're all correct, you write down all the letters. If 3 are correct and the other 2 are not, write down the ones that are correct. And what it has to do with, folks, is if you remember how to expand and condense logs. That's what it has to do with. It has 5 different things. It says this is equal to this. Yes or no? It has to do with condensing things and using the change of base rule. Condensing and expanding, okay? That's all I'm going to tell you about it.
That's 21.
Yes. No, that's the multiple response number 1, which is 21 essentially. Okay? So there are 5 equations having to do with expanding, condensing, and using the change of base rule. And you got to pick out the ones that are right. Numeric response, number 1. That's the other Newton's law of cooling one, where you have to plug and chug, basically. It's the one where it says, here's a cup of soup at this temperature. It cools to this temperature and this temperature of surrounding air, and the rate of decay, which is the R value, gives you that. And it says, how long will it take to happen? You've got to solve for t, little t. Remember doing that yesterday? Okay, again.
Does that one have the equation?
It does. It has exactly the same thing
That's 20.
written out. Yeah. So it gives you the equation, tells you what they stand for. 2 different types of problems. In the first one, you got to find little r and use it to find capital T. In this one, they give you everything except for little t, and you got to find a little t with log. Okay. You got to isolate the t. Same Newton's law of cooling, and it gives it to you twice. Last thing, and most people do fine with this, but some people get a bad thought in their mind. I'm going to try to not let you do that. I'll tell you what it's about. I tell you what the bad thought is as I go through, and hopefully you won't make that mistake. It says, well, by the way, this is called other number 1. And that's what I have down here, other number 1, and it has 3 parts. Okay, so it's titled just like it is on the test, so you can't get too confused. And it says, the value of a home in thousands of dollars can be approximated by this model. It gives you a model, and I'll make one up here. Y equals 311 times 1.04 to the t. Okay, so let me read that again so you got something to reference. It says the value of a home, Y, that's the value of the home, Y in thousands of dollars can be approximated by this model. That's the equation. Where t is the number of years since, we'll say, 2005. So the home was purchased in 2005. That's when t was 0. Okay? Here are the questions dealing with that. Tell whether the model represents exponential growth or exponential decay. What is it? How can you tell? Because this that we use over and over and over again is bigger than 1. It's got to grow. If this were 0.98, then they're in a slummy area and their house is losing value year after year, and you would say decay. Are you with me? Okay. B part, most people don't miss that part. B part. Identify the annual percent increase or decrease in the value of the home. Say 4% increase. Because this is the same thing as writing it like this. is your growth or decay rate. Remember, I told you this is the factor, but this is the rate. And the question asks, identify the annual percent increase or decrease in the value of the home. They don't actually use the word rate, but that's what's identified right here. This holds on to the value of the home. This lets it grow by 4% a year. Y'all see it? If it had been, as I said before, 0.98, then you would say 2% decrease per year. Got it? Because that's the same thing as 1 minus 0.02 to get to the 0.98, and that's your decay rate. Are we clear? People don't miss that either once they have it pointed out. This is the part they miss. And it says, estimate the year when the value of the home will be $380,000. Estimate the year when the value of the home will be $380,000. How do we handle that? Plug what into the Y? 380,000, right? And the answer is no, that is not what you do, and that's what kills people. You put that in for Y. I read it twice, and it ran right over the top of your head because nobody was listening. Nobody was reading. People don't read. This says the value of a home Y in thousands of dollars. There is no way that the home could have been worth $311 in 2005. That's what you're indicating here if you put this many zeros on here. This is $311,000 purchase price. We want to know when it will get to $380,000 purchase price. If you put the 3 zeros on here, you're asking, when will it get to $380 million worth? And that will take several centuries. Maybe never, I don't know. But you understand that this is the way you write this. Because of that little thing in parentheses that everybody just lets their mind gloss over, and you have to be careful. How do we solve it now? If we put this correct thing in.
Divided by 311.
You take 380, yep, you're exactly right, divided by 311. Get that done first to isolate the exponent. Now what? Log, common log or natural log? It doesn't matter because we're not using log base 104. If that were e to the t, then we would use natural log because it makes things just slightly easier. We don't want to use log base 104. You can if you want. That would be ridiculous. Use one of the buttons you have. You want to use common log or natural? Doesn't matter. Common? Then what we will do is common log this fraction equals t common log of 1.04. You see that? That's what's happening when I log both sides or not? Log the fraction. When you log this side, because it has an exponent, it gets to crawl down around front here. Now it's times the log of 104. So the final answer to calculate will be the log of this fraction divided by the log of 1.04. Grab a calculator, crank that out. Do log 380 divided by 311 divided by, close, make sure you close that parenthesis. Log 1.04. Close that, enter. So how will you answer the question? Right? That's where the fact that it started in 2005 comes in. I got 5 years it will take to reach 380,000 at that rate. To reach this, 5 years. If you write 5 in that blank, I'll understand what you did, but you didn't complete the question. It said, when will it happen? They expect you to pay attention to the years. If it began in 2005, then 5 years later is 2010. So in the year 2010, it reached a $380,000 value. So you have to answer it with a year because they gave you years in it. Are you with me? See what's going on? Okay, folks, that is the test. And That's the end of the test review. So I'm gonna stop this and I will mail it all to you. If anybody wants to view it, you can. See you, bye.